Yes, you have learned about the sets and the Venn diagram. It's now time we see how we can be able to incorporate the probability when dealing with the Venn diagram. Now, everybody knows that probability is simply the likelihood of an event to occur. So if I'm given the Venn diagram or the sets, I can simply be able to calculate the probability of a given event, going to occur. Now, given that all that particular events all of them are likely to occur, are equally likely to occur, we can be able to calculate the probability of, let's say, set A, or picking an element from the set A. Now remember, if you're calculating the probability, we must be having a sample space. Now for this case, the sample space is going to be the universal set, or the set under discussion. Now, for example, if I have this one as my two sets, let me use this as a set A, and this one is a set B. Of course, of a Venn diagram, we must be having this enclosure here. So let's say this is our set A, and this one here is our set B. Now, in between those set A and set B, the intersection of it is those elements that are appearing both in set A and set B. Now, an example. For example, if you have, if you're told to get the probability of, let's say, picking members from set A, or of an event A occurring, we simply take the cardinality of set A. That means the total number of members which are in A, then divided by the total number of elements under discussion, which we call it in this case the universal set. So given the members of A and you're given the universal set, we can be able to calculate that likelihood of A occurring. Now, same thing. Now remember, in sets, we normally have intersection of sets, the union of sets. So intersection means the region which is shared in between them. So what will be the probability of now picking the element which is appearing both in set A and in set B? That one becomes the A intersection B. So the probability of A intersection B is going to be given as we take the cardinality, or the number of elements that are in both A and B there. We count them. Cardinal means the numbers of them. If you count them, then they divide by the universal set, or the set under discussion. Now, the same thing we can calculate also the likelihood or the probability of picking the probability of picking element in both in A and B, combine all of them. We call it A or B or both. So this one is going to be given us. We take the cardinality of A union B, and then divide by the cardinality of the set, the universal set, or the set intersection. Now remember, the set not the set intersection, that the universal set, which in this case is our sample space in the probability. Now let's pick an example here and see how we can be able to calculate. Now we have 27 students in a class, and out of these 27 students, 12 are having black hair, and the 17 are having brown eyes. And then we have 9 students. We have 9 students here who are having both the black hair and the brown eyes. Now, for us to calculate the probability, we need to put all this information on the Venn diagram. Now, remember, we have 27 students. So our sample space is going to be 27. Our sample space is going to be 27. Now, let's start with part A. Now, part A says, draw a Venn diagram to show this information. Now, we have 2 sets. So if I draw this is the first set, and this is the second set. So I have to enclose it in this one here. Now let's choose the letters we are going to use. Now for the 12 black hair, 12 students who have black hair, we can pick H to present black hair, then the brown eyes. Let's use this one as let the black hair be B, and then the brown eyes, let's use it as R. Okay, so this is set B, and then this one is set R. Okay, now since we are not given the letters, so we are at liberty to choose our letters so long as we are defining them there. Okay, now let's fill in the members of these two sets. Let's fill in the members of these two sets. Now we are being told now 9 students have both. If they have both, which means that one is a shared region. So let me pick a different ink here, shouting ink a little bit. Let me pick green here. Now 9 is appearing both sides, so I'll put 9 here. Okay, I'll put 9 there, and then at the same time you're told the 12 students have black hair. So we already have others already captured in between. They're having black hair and the brown eyes. So 9 is already captured. So the remaining one here is going to be, then will be remaining one to reach 12. There will be 3. So 3 are remaining there. And then when you go to brown eyes, if you go to brown eyes, we have 17 of them. So 17, and among those 17, 9 are appearing both sides here. So the one remaining is only 8. The one remaining is 8. So such that when you now take 9 plus 8, it will give you back the 17, a total of students who are having brown eyes. And then if you take 3 plus 9, it will give us 12. Those are the total students who are having black hair. Okay. Now let's check how many are remaining outside. Who doesn't have brown hair or black eyes? So if you add inside here, this one is giving us 10. That'll be 18. 9 plus 8, that is 17. And then 17 plus 3. 17 plus 3, this one is giving us 20. So out of 20 students have either black or red eyes. So our sample space was 27, that is universal set. It means 7 are remaining. They don't have either. They don't have brown eyes, nor they don't have the black hair. Now, after presenting our Venn diagram, we can now go to part B. Now, this is where it's now involving the probability. The first part says what the probability that the student picked at the random from this class, a class of 27 students, that he's going to have, he has a black hair and a brown eyes. And means in that case, he has both two. He has a black hair and he also has a brown eyes. Those two things at the same time. So it means it is intersection. So they want us to get the probability. Let me check a different ink here is okay. So for this case, they want us to get the probability. They want us to get the probability of B intersection R. The probability of B intersection R. Probability of B intersection R is going to be, remember we said take the cardinality of B intersection R. So it's going to be equals to the cardinality of set B intersection R, and then divided by the universal set. We divide by the universal set. So B intersection R is 9, then divided by the universal set is 27. Now this fraction simplifies to 1 out of 3. Okay, now let's go next one. The probability of picking a student who has a black hair or a brown eyes, or that means he has either he is having a brown or he has a black eye. That is a union. The two of them, check the union. So they're simply going to be B union R. They're simply going to be B union R. So if you pick a student, the likelihood of picking a student who has a brown or a red eye. So it'll be the cardinality. This is going to be the cardinality of B union R. Then we divide it with the universal set here. Now B union R is going to be 20. We found it is 20 out of 27. So there's no number to simplify it, so that one remains our answer. Now let's go to the last part here. Roman 3 says has black hair but not a brown eyes. Has a black hair but not a brown eyes, which means we're not going to pick the one which is having a black and brown. So we only have 3 students who are only having black hair but not a brown eye. So the probability of that one is simply going to be equals to, the probability of that one is simply going to be equals to 3 out of 27. 3 out of 27, which is equals to 1 out of 9. Now, if you want to present in terms of the set notation, that one simply is going to be the probability of B, and then probability of B intersection R complement. A bit of R complement. Now, let's go to the next one here. This one is saying you pick the probability that does not have, the student does not have a black hair or a brown eyes, which means neither does not have a brown and does not have a black hair. So it means the one which is outside here, this one. So we are going to pick it 7 students, they don't have either of 2 of them. So 7 out of, it will be 7 out of 27 from our sample space. It will be 7 out of 27. Now, if you want to present it in terms of the set notation, if you're given terms, that is the same as having the probability, that is the same as having the probability of B union R and then complement. That's B union R complement. B union R complement. No? Okay, so that one, if we are given the 2 sets, can also still happen with the 3 set problem. You can still have it with a 3 set problem, so long as you know if they're asking about the intersection or the union, you simply pick the required value. Now, let's move a little bit now further to go to a little bit more challenging part now, a conditional probability when it is involving the Venn diagram. Conditional probability involving the Venn diagram. Now, conditional probability here means we're simply going to only select a subset of the subset of that given set, the subset of we're simply going to select a subset in the Venn diagram. Now, I want us to pick this question as an example. Okay, for definition here, so P, probability of getting, it is presented as, let's say we have 2 sets A and B, A given the B, So this is simply going to be equals to, let me pick a different ink here for presentation here, present on this one. So probability of picking A given the B is going to be equals to probability of A, this line means given the B, will be equals to, we take, it is going to be A intersection B, and then divided by the probability of the set cardinality of B, the set cardinality of B, the cardinality of it. Now, what does it mean? It means the event B has already happened. It means the event B has already happened. So if the event B has already happened, what the likelihood of now event A following on it? Okay, let's take this one as an example and see how we can be able to handle a condition. So it's an event which is depending on another event to occur. Okay, now let's take this one as an example. In a class of 60 students, 25 students passed the first term exam, and then 38 students passed the second term exam, and then the 20 students have passed both exam. Now remember, all this information must first be put into the Venn diagram. Then after the Venn diagram, that's when you can be able to calculate the probability. So part A here, we are told draw a Venn diagram to represent the above information. So let's draw the Venn diagram first. So this is my Venn diagram up to here. Now, let's select a letter. Since we are not given the letter, we are at liberty now to select letter to present the first exam and the second exam. Okay, for first term exam, let's use F for first term exam, and then let's use S for second term exam. So set F represent the set of people who have passed the first term exam, and then S represents the student who have passed the second term exam. Now let's try to represent the information in this Venn diagram. So say 25 students passed the first term exam. Now we cannot put here 25, reason because we might be having students who have passed first term exam and they have gone ahead and passed second term exam. So not all 25 are going to be here. So we can be having student. We can be having a student who have passed. We can be having a student who have passed second term exam, but they have failed the first term exam. We can also have a student who have, out of these 60, who have failed both exams. So let's check. Now let's start the first one here. I'll pick a different ink here so that you can be able to have different one here. Is okay. Now, oh, there's a blue. It's the same as the question. I'll pick. Okay, let me pick this one for that case. Now, are we given the both? We have 20 students who have passed both exams. They have passed the first term exam and the second term exam. So those students are going to be presented here. Okay, they are going to be presented here. We can put it in the middle here. So those one, they have passed first term and they have passed second term exam. Now let's go now to people who have passed the first term exam. The people who have passed first term exam here are total 25, which means here you can put 5. So that 5 plus 20, it will give us 25, the total of students who passed the first term exam. Then the second term exam, there are a total of 38 students who passed the second term exam. So they can, we have 20 passed first and they have passed also second. So in total, we are going to have 38. So we must be having here 18 students. So that you take 20 plus 18, it now gives you 38. It now gives you 38. Or simply we take 38, then subtract it with the 20, which now gives us 18, which you present it on that side. Now let's check how many students we have already now presented both in this particular Venn diagram. Remember, we also have the universal set. Okay, so 60 students. Let's add and see if they add up to 60. If they don't add up to 60, those remaining one are the one who failed the first term exam and the second term exam. Now let's add 5 plus 20, that become 25. Okay, you have 38. 38 plus 5. 38 plus 5. This one gives us, this would be 3. Carry 1, that becomes 43. 43. So, but they must add up to 60. So we now take 60 minus 43 to see how many now failed exam, which will be presented outside here of that two sets. So that will be 7 and 1. So we have 17 students who failed both the first term exam and the second term examination. Or the first term exam and the second term exam, that's 17. Now let's look at the probability now. The first question A says, find the probability that the student selected at random in that class of 60. Now remember, our sample space is 60 now. Out of 60 students for part A, out of 60 students, say, calculate the probability that the student who is going to be selected has passed both exams. Has passed both exams. Now, both exams, which means that is intersection of first term exam and the second term exam. So the same as saying it is the probability of F intersection S. The probability of F intersection S, S is going to be equals to 20 divided by the sample space, which was 60. Okay, so this one gives us 1/3. This gives us 1/3. Now the second one says he has failed the exam. They are not in the first term or second term exam. That means it's going to be the complement of that one. Now it is the complement of F union S. They are not either in this one or in this one. So it's simply going to be, those are 17 students out of 60. 17 students out of 60, that's the probability of it. Now, Roman 3 says, find the probability that the student who is going to be selected has passed the second term exam. He passed the second exam, given that he passed the first term exam. Now, our sample space here is going to change now. Okay, that's where now it's called the conditional probability. So the condition here is that the student who is going to be selected, he has passed the second term exam, but he has already previously passed the previous exam. So it means it's going to be this means it's going to be 20. It will be 20 out of 25. Now let's check what will be our sample space here going to be. So the probability of second, he has passed the second exam. He has passed the second exam, which is a probability of passed the second exam given the first term exam. Given the first term exam. Given the first. So that line means a given, or that event has already happened. So we pick S given that F, he has already passed the first term. He has already passed the first term exam. Okay, so second term exam, but he has already passed the first term exam. So our sample space now becomes this one. Now, if you can be able to recall where we started here, we said we pick the cardinality of A intersection B, then divided by the cardinality of B. So this one now becomes our sample space. So we no longer now use the universal set as our sample space. So now this becomes, so it means we're only picking students who have passed the first term exam. Okay, we're picking among the students who passed the first term exam, and they have passed now this second term. They have now passed the second term exam. So that's going to be equals to, that one is going to be equals to, sorry, just a minute. That's going to be equals to 5. The second, you have passed the second term exam, has passed the second term exam, given he passed the first term exam. So it's going to be 20. It's going to be 20. It's going to be 20 out of 25. 20 out of 25. 20 out of 25, which is the same as simply saying we take the probability of S intersection F and then divide by, okay, let me change this one, the cardinality, the same as the cardinality of S intersection F, and then divided by the cardinality of F, divided by the cardinality of F. So now we can now simplify here. 5 gives here 4 and 5 gives here 5. So simplify becomes 4 out of 5. Now, most of the time you're going to be given in terms of, you're already given, let's say, A intersection B, F intersection S. So we simply, also you're only given in terms of words, we can simply be able to interpret it in terms of the set notation, and then you select the required part. Now let's go to the second question from the textbook. Let's look at the second question. This one's coming from the textbook. That takes us 2-star, challenging question on it. 2-star. No, let's check. So the question said the Venn diagram shows customers' choice of cheese. The Venn diagram shows customers' So choice of cheese presented by C, and then the tuna is T and egg is E. They were selecting which one to fill in the fill in the sandwich. So we have those one who picked cheese. There's those who picked tuna. That's the fish, and then those people who picked eggs represented by E. Okay. Now we're being told in that particular cave. So if you're told now how many customers were in that cave that duration, so we add all of them: 6 plus 5 plus 12 plus 15 plus 1 plus 23 plus 8, which now becomes our sample space or the universal set. Now remember, when you look at this particular the Venn diagram, we don't have any member outside here, which means all the customers ate they ate this particular sandwich having either tuna, an egg, or a cheese inside it. So none ate just a sandwich without anything inside it. Okay. Now let's check the first one. It says how many people choose all the three fillings. All the three filling means we pick now this intersection or among the three, all of them. Those one are equals to, there were 12 of them. The 12 of them, they say mix for me, or everything. Mix for me, tuna, egg, and mix for me, tuna, egg, and the filling. Those are 12 of them. They choose the three fillings. Now, let's go to part B. Part B says, work out now the probability of T intersection E. Probability of T intersection E. Probability of T intersection E. Now, remember, we first need to get the sample space. We first need to get the sample space inside this one. Now, the sample space for this case is going to be equal to, the sample space inside this one is going to be equal to, we add up 12, 12 plus 8 will be 20, 20 plus 5, 25, so 25 plus 23, 25 plus 23, that gives us 48, and then 48 plus 16, 48 plus 16, that'll become 64, 64, then 64 plus 6, 64 plus 6, this one gives us 70. So it means they had 70, a total of 70 customers in that particular, they had a total of 70 customers in that particular restaurant, in that day, in that cave. Now, work out the probability of picking T intersection E. The people who chose tuna and egg, tuna and egg, tuna and eggs, tuna and eggs. Now remember, we are picking the intersection tuna and egg to be this one, between tuna and egg. So it will be equals to, let me have it here as my Roman one, should be the probability of tuna intersection eggs is going to be equals to, we take the cardinality of T intersection E, then we divide it with the cardinality of the universal set, or the set under discussion, the total number of customers who came that day. So for this one is going to be equals to, that one is going to be equals to 12 plus 23. So we take 12 plus 23. That's the intersection of two of them between tuna and eggs. 23. So that'll be 5. That'll be, this will be equals to, it will be 2, 5. That'll be a total of 25. So this becomes 25 out of the total, which is 70. Now that fraction has to be simplified. Now we go next one. Can simplify that one. Now next one, Roman 2. Roman 2 says the probability of picking P intersection C, C intersection T intersection E, which means the one which is appearing in 3 of them, all of them. That one is going to be equals to it is 12 out of, that one is 12 out of 70. Now remember, our probability has to be simplified. Now, in a conditional probability, Roman 3 is the one now bringing out the conditional probability. Now, let's check E, the probability of E, given he chose C. Given the event C has already happened, this C and E only. We are simply going to deal with C and E only. So those two sets. Space now changes. So for this one is going to be equals to, we are going to take the cardinality of E intersection C over the cardinality of C over the cardinality of C. So it means they are picking the customers among the customer who already they have chosen the cheese already. Okay, they have already chosen the cheese. Now, if he has now chosen the egg, so what the probability of picking a customer who has picked egg, but previously he already chose he already picked a cheese. Okay, so the intersection of E and E will be 15. That is 15 plus 12. 15 plus 12, which gives us 27. So it's going to be equals to 27. It'll be 27 out of. Now, cardinality of C, that'll be 27 plus 11. 27 plus that will be 30. Gives us 38 out of 38. Out of 38. Now, the question has to be exercised here when you're now looking at the conditional probability. This one is not condition, this is not condition, but this one is a conditional probability. Okay, which means that they are picking the customer who has picked, who are picking the egg, but they must have previously picked what? The cheese, which means our sample space is those customer who picked cheese, and they're now picking the eggs. Okay. Now, thank you for the part of us. We will pick it from there next time. Thank you.